Okay, that, ladies and gents, was a band called 311. But again, I'm gonna probably guess you guys are way too young to even know who those bands, or that band is. And if you do, you're awesome. Good for you. And if you don't, hey, look them up. But yeah, they're old, man. Look at that, 93 to 2003. When were you guys born? Like 98, 99, maybe. I am certainly getting old, but this might be one of the best bands ever. So definitely worth looking into. If you like music. So here we have it, the white proof. Here we go. This is one that caused a lot of people some problems in class, and for good reason. It's pretty tough. But step one, you guys know what's about to happen. We have to evaluate what's going on here. We have to understand the proof first if we have any hopes of actually proving it. So by watching my other videos, if you watch my other videos, you guys know what I'm about to do. I don't like these three-letter things, man. Those confuse me. So I'm going to call this one angle 1. I'm going to call this guy angle 2. So angle 1, ABD, angle 2, EFH. Hey, we might as well name this 3 and 4 while we're at it. So we have to prove these are indeed congruent. Well, how do I do that? Look at my givens. I'm giving some perpendicular lines. AB is perpendicular to BC. EF is perpendicular to EFG. I'm sorry. EF is perpendicular to FG. I kind of misspoke there. What does that tell me? That means these are right angles. Perpendicularity gives me right angles. If these are right angles, that means they're 90 degrees. Okay, what does that tell me? That doesn't really get me anywhere. That doesn't get me any closer to angle 1 being congruent to angle 2. Okay. Look at my other given, though. These are angle bisectors. There's BD and FH going through the middle are angle bisectors. Well, what does that mean? Bisectors cut things in half. So bisectors make two congruent angles. That means this angle is congruent to this angle. So let's think about that. If these two angles are exactly the same angle and measure, and the entire angle is 90, doesn't it stand to reason that if I divide 90 by 2, I get 45? And if this is 45, it has to be true on this side. Guys, that's why they're congruent. They both have the same measurement. That's how we're going to prove this. So let's think about these steps. We have to establish the 90-degree angle here and here, of course. We then have to use the definition of bisector to show that they're congruent, the measurements are the same, and to perform a division problem. That's how this proof is going to run. Lots of steps involved, so be prepared. Also, another thing to kind of let you know right off the bat, all the stuff I'm going to do on the left is going to be the same as the stuff I do on the right. So I'm not going to write all the stuff on the left and then basically start a new proof for the one on the right. I'm going to try to write the steps together. I'm going to try to shortcut that by putting the steps together. So that is what you are about to see. So let us begin this journey. Also a great band. All right. So in class today, overwhelmingly, people were writing two-column proofs, which I think is fantastic. Keep writing those two-column proofs. I don't like them personally, but I will humor you guys. If that's what you guys are writing, that's what I should show you here. So here is my two-column proof. Instead of writing them by hand, which I've done before, I'm going to use my line tool. Why not? It's available to me. I'm going to do it. Over here we have our what's. Over here we have our whys. In other words, here's my statements, here's my justifications. Let's go ahead and jump right into the givens. I mean, that's where I should really start anyway. So let's see. I have AB perpendicular to BC. I have EF perpendicular to FG. That's going to be given to me. But the more important part is now I have this structure in place. What can I tell as a result? Like if I know that I have these perpendicular intersections, what should I know automatically? Well, hopefully you guys are picking this out, that we have some right angles. Angle ABC and angle EFG are right. And that's why I'm going to go ahead and abbreviate that, but that's a right as in right angle. So in other words, if these are perpendicular, the angles as a result are right angles. Notice I didn't jump to 90 degrees, which is a mistake I saw a lot of people make in class today. The definition of perpendicularity, a definition of perpendicular is a structure, the relationships are right angles. Relationships give you numbers. So that's what you're going to see in this next step. Structure, relationship, number. So if I know the right angles, and by definition of what it means to be right, they should equal 90 degrees in terms of their measurement. Okay. All right, so we have the measurements of each of these big angles equal to 90 degrees. Now, I'm just replacing some of the things I had when we were evaluating. Again, I think it's much, much easier to talk about angles as a direct name versus a three-letter naming convention. Hope you guys are adopting that too. If not, totally cool. You don't have to. You keep using 3 letters if that is what you like. So I have to get these angles in the mix. Like, I don't care about angle ABC. I care about angle 1. So I have to somehow relate angle 1 and angle 2, of course, to ABC and EFG. But look, I have a way to do that. If I add angle 1 to angle 3, I get the entire angle. If I add the measurement of 2 to the measurement of 4, I get the entire angle. I can make that a statement. I need to somehow translate angle 1 to ABC. So here's how I'm going to do that. So the measurement of angle ABC is equal to the measurement. Look at that equal sign. Come on. Angle 1 plus the measurement of angle 3. Likewise, the measurement of angle EFG is equal to the measurement of angle 2 plus the measurement of angle 4. How do I know that? Well, I think I just told you guys. I'm adding angles together. That's angle addition postulate. Just like segment addition postulate, which states that I can add smaller segments together to get the full segment, I can add individual angles together to get the full angle. That's all you're seeing there. I could probably make one more connection because I know if I'm going to show congruency, I got to show measurement. I actually have a number here in terms of measurement. Let's replace that. ABC is the same as 90, 90 is the same as EFG. So I can definitely claim that 90 degrees is the same as a measurement of angle 1 plus a measurement of angle 3. And 90 degrees is the same as a measurement of angle 2 plus a measurement of angle 4. Okay, and that's going to be substitution. Okay, let me switch colors up here. All right, so that's about all I can squeeze out of that given. Notice I didn't say anything about bisectors yet. I'm going to do that actually next. I use a given that I actually needed for the right angle. I'm going to use this given in this proof now. There's no rule that says you have to write all your givens first. It's just a good suggestion. But as you guys are getting to be more advanced proof writers, certainly you'll see that's not always the best thing to do. So let's go ahead and put our second given in. We have 2 bisectors, angle bisectors, DB and FH. And that's going to be because they are given to be so. Okay, so we have structures. We have these angle bisectors. So what relationship can we get from these structures? Remember, structures, relationships, and then numbers. Well, if they're bisectors, I don't know that the measurements are equal, but because that's, again, talking about numbers. The relationship, though, is that the angles are the same, hence congruent. That's what's coming next. So if DB and FH are actually bisectors, I know that angle 1 is congruent to angle 3, and on the other side, angle 2 is congruent to angle 4. And this is what the definition of bisecting means. Well, again, if I'm talking about measurements, I want measurements to prove congruency. I need to actually convert these in. But if they're congruent, that's an easy conversion. I know the measurement of angle 1 is the same as a measurement of angle 3, and the measurement of angle 2 is the same as a measurement of angle 4. Again, we're talking definitions here, right? So this is going to be the definition of congruency. If they're congruent, the measurements are the same. All right, so I have all the pieces I need. Now, you said the last thing we had to do was some division. I have these statements in 5 where I have 1 plus 3 is equal to 90. 2 plus 4 is equal to 90. Guys, I don't care about 3 and 4. I don't need 3 and 4 up here. I need to actually exchange these. I need the statement to equal 90, but I don't want it to have angle 3 in it. In fact, I'd like it to have just angle 1. Man, if there's only a way I could take out the 3 and put a 1 in its place. Oh, look what I'm circling over here. Angle 1 and angle 3 we just established to be the same. If they're the same, then they're substitutable. So in this step, I'm actually going to rewrite these 2 equations. 90 is going to be the same as a measure of angle 1 plus a measure of angle 1. 90 is also going to be the same as a measure of angle 2 plus a measure of angle 2. I accomplished that by doing some substitution. Okay, in other words, I took out the 3 and put a 1 in its place, and I substitute using this step. I took out the 4 and put a 2 in its place, again substituting using this step. Okay, well, we'll check it out. If two angles that are both 1 add to 90, that's got to be 45. Same thing here. If two angles that are both angled 2 add to 90, they're both 45 degrees. They have to be. So I can claim the measurement of angle 1 equals 45, which is also the measurement of angle 2. How can I claim that? Pretty simple. I solved it. Okay. Well, if angle 1 is 45, which is the same as measure of angle 2, they have to be congruent. They have no choice. They've got to be congruent, because if the measurements are the same, then by definition, the angles themselves are congruent. Okay, I am done. That finishes my proof. I had to prove that angle 1 is congruent to angle 2. I have done so. Okay, so again, bigger proof. As you guys can see, these proofs got really hard really fast, but I'm glad you guys are taking time to study, prepare yourself for your quiz tomorrow. Again, I'm going to post these on Edmodo. In fact, I'm going to start posting right here in about 5 seconds. So if you guys have additional questions, please post them. I'm also available on Edmodo or all these proofs, so if you didn't have them, maybe lost them, didn't grab one or download it tonight and get to work, man. I mean, that's what these are here to do, just provide you guys with extra study material. Something to kind of consider is that if you can't type out a question because it won't make sense if you type it, maybe post a video. You guys have the ability to post a video on this just like you could on Facebook. So maybe post me a video question. I'll try to respond to it. I'm going to be monitoring Edmodo probably about 10 o'clock tonight, so please be using that as a resource. Thank you guys so much for studying and stopping by. Good luck tomorrow. Okay, so please study hard tonight. I'll see you all tomorrow.